to continue the next point, and that is the spontaneity and the delta H or delta Z. Here the relation between spontaneity of reaction depends on delta H and values of delta S. You know the delta Z is equal to delta H minus T delta S at constant temperature and pressure. And here the values. The value of delta H change in enthalpy, delta S means change in entropy, and delta Z means change in Gibbs energy. Here we have two values of each process. Delta H is positive or negative, delta Z positive or negative, delta S positive or negative, and then the spontaneity of reaction means that reaction is spontaneous, non-spontaneous, or equilibrium. Here we see one by one the spontaneity and delta H and delta H. Here delta H is a negative. The value of delta H is negative. Then delta S is positive. The value of delta S is positive. And then value of delta Z is negative. Delta H negative, delta S positive, delta Z negative. That time, the reaction is a spontaneous. The reaction is spontaneous at all temperature. At all temperature. ऐसा से तो reaction का ऐसे all temperature का ऐसे spontaneous. Second. And this reaction delta H is negative means the reaction is exothermic. And then this delta S negative, delta H negative, delta S negative, and delta Z is positive or negative. Or minus positive or negative. Positive or negative. That time the reaction is spontaneous. The reaction is spontaneous at low temperature. Reaction gas is spontaneous at low temperature. Delta H negative. Here delta S negative. Then third case. Here this is delta H positive. Delta S positive, then delta Z negative or positive. Or positive. The reaction is spontaneous at high temperature. The reaction is spontaneous at high temperature. As a change of the our reaction is exothermic reaction. Depends upon the value of delta H. And here endothermic. Depends upon the value of delta H. Here delta, the next value. Here positive. Delta H positive. Then delta S negative, positive negative. Here delta Z positive. And the reaction is a non-spontaneous. Non-spontaneous at all temperatures. Reaction is non-spontaneous at all temperature. Non-spontaneous at all temperature. And here this spontaneity is dependent. Here these two are exothermic reaction, these are the endothermic reaction. Here this, in this case delta H negative, then delta S positive, delta G negative, spontaneous at all temperature. Second, delta H negative, delta S negative, delta G positive or negative, spontaneous at low temperature. Third, in case of endothermic reaction, delta H positive, delta S positive, delta G positive or negative, the reaction is spontaneous at high temperature. And both the case, delta H positive, delta S negative, delta G positive, and thus non-spontaneous at all temperature. First case में spontaneous at all temperature and non-spontaneous at all temperature. And this is the spontaneity and value of delta G, delta H, and delta S. And then next point, temperature of equilibrium. Temperature of equilibrium. Next point, temperature of equilibrium. And here we see the reaction is spontaneous and the values of delta C, delta H, and delta S. Then now see next, temperature of equilibrium. Temperature of equilibrium. Temperature of equilibrium. Temperature of equilibrium. For equilibrium reaction, delta Z is equal to, at equilibrium delta Z is equal to delta H minus P delta S. Means at equilibrium is change in gives energy is equal to change in enthalpy minus temperature into change in entropy. Here T is equal to, hence T is equal to delta H upon delta S. T is equal to delta H upon delta S. Here we calculate the temperature from these two values of delta H and delta S. The change in enthalpy and change in entropy. And T is the temperature. Then delta H means change in enthalpy and delta S change in entropy. Here this is the temperature of equilibrium. And then next we see Gibbs function and equilibrium constant. Gibbs function and equilibrium constant. We see the last derivation in the chapter, that is the Gibbs functions and equilibrium constants. Gibbs functions and equilibrium constant. Equilibrium constant. Here this is the relation between Gibbs function. Gibbs function means now G is called as Gibbs energy, then delta G is called as change in Gibbs energy. And the equilibrium constant means the Kc and Kp. Kc and Kp. Kc means equilibrium concentration and Kp means partial pressures. And now we continue to know the change in Gibbs energy is equal to delta Z is equal to delta Z is equal to delta Z0, means change in Gibbs energy is equal to standard Gibbs energy, standard change in Gibbs energy plus RT ln Q. ln means ln is called as ln is equal to log to base E. Log to base E. And the Q means reaction quotient. reaction quotient is Q is equal to molar concentration of product upon molar concentration of reactant. And here we consider a one reaction and we calculate the molar concentrations of that reaction. Consider a general reaction. That reaction is here A into A plus B into B gives out C into C plus D into D. Here molar concentration of A, B, C, D are the molar concentrations of that reaction. Here, and our reaction at molar concentrations means the delta Z means change in enthalpy is equal to standard Gibbs energy plus RT into ln QC means molar concentrations. QC means equilibrium constant for molar concentration. Then is equal to delta Z0 means standard Gibbs energy plus RT into ln means molar concentration of reactant upon molar concentration of product upon reactant. Here molar concentration of product, molar concentration of C raised to C into molar concentration of D raised to D upon molar concentration of A raised to A into molar concentration of B raised to B. These are the molar concentration. And here this is the equation number first. And then for QP हे जे आपण काढलं हे कॉन्सन्ट्रेशन ला काढलं. जर तुमचे रिएक्टंट आणि प्रोडक्ट काय असतील गॅसेस फॉर्म मध्ये असतील तर त्याला कॉन्सन्ट्रेशन नाही घ्यायचे तर काय घ्यायचे असतात पार्शियल फ्रॅक्शन. म्हणून आपण हे इक्वेशन कशाला घ्यायचं आहे QP साठी घ्यायचे जे और QP साठी काय डेल्टा Z इज इक्वल टू स्टैंडर्ड गिव्स एनर्जी प्लस RT into ln QP. P means partial pressures, and the reaction is delta Z0 is plus RT into ln the partial pressures of here partial pressure of C raised to C into partial pressure of D raised to D upon partial pressure of A raised to A into partial pressure of B raised to B, and this is the second equation. And then we see here this equation for molar concentration. This equation for partial pressures. ज्या तुमचे रिएक्टंट आणि प्रोडक्ट काय असतील कॉन्सन्ट्रेशन्स असतील त्या हे इक्वेशन यूज करायचं. तर तुमचे रिएक्शन काय असेल गॅसेस फॉर्म मध्ये असेल तर काय करायचं असतं हे पार्शियल प्रेशर त्याचे घ्यायचे काय करायचे मोलर कॉन्सन्ट्रेशन करायचं असतं. And then the reaction reaches at equilibrium. That time delta Z is equal to 0. The reaction is reach at equilibrium. That time delta Z is equal to 0. And QC and QP is equal to KC and KP. Here at equilibrium, the reaction is reached at equilibrium. That time delta Z is equal to 0 and KC is converted into QC is converted into KC and QP is converted into KP. Then Here delta Z is equal to 0. At equilibrium, delta Z is equal to 0. Then 0 is equal to this equation. Delta Z is equal to delta Z 0 plus RT ln Kc. हे इक्वेशन झालं सगळ्यांचे. या इक्वेशनचं काय त्याच्यामध्ये आपण करायचं. And the equation KT चं KT ला Q ला कशामध्ये कन्वर्ट करायचं KT मध्ये. And at equilibrium force 0 is equal to delta Z0 plus RT ln KT. म्हणजे for equilibrium constant and partial pressures. or तर या इक्वेशन मध्ये आपल्याला थोडासा चेंज करायचा आहे. काय 0 इज इक्वल टू त्या व्हॅल्यू आहे आणि काय इक्विलिब्रियम प्रोसेस मध्ये. तर आपण काय करायचं आहे, तर डेल्टा Z0 कडे घ्यायचं. काय म्हणा डेल्टा Z0 म्हणजे स्टँडर्ड एनर्जी इज इक्वल टू मायनस RT ln Kc आणि दुसरं सेकंड काय राहणार आहे and delta Z0 is equal to minus RT ln K. For equilibrium constant and for partial pressures. Then and this is the equation number 3. This is the equation 3. When we change the log to base, it is converted into log to base 10. Then equation is this log to base it is converted into log to base 10. That time the delta Z0 is equal to minus 2.303 RT log to base 10 into Kc. And here delta Z0 is equal to minus 2.03 RT log to base 10 K. आणि हे दोन आपल्याला काय मिळतात इक्वेशन मिळतात. हे डेरिव्हेशन आहे. स्टँडर्ड gives energy is equal to minus 2.03 RT into log to base 10 Kc. आणि हे दुसरं आहे हे तुम्ही डिसाइड करायचं आहे. तुम्हाला प्रॉब्लेम सॉल्व्ह करत असताना तुमच्या व्हॅल्यू दिलेली आहे ह्या कॉन्सन्ट्रेशनच्या दिलेल्या आहेत का पार्शियल प्रेशरच्या दिलेल्या आहेत. जर तुमच्या व्हॅल्यू कॉन्सन्ट्रेशन मध्ये दिल्या असतील तर तुम्ही हे इक्वेशन यूज करायचं आहे प्रॉब्लेम सॉल्व्ह करता. आणि जर तुमच्या व्हॅल्यू कशामध्ये असतील पार्शियल प्रेशर मध्ये असतील तर तुम्ही काय करायचं आहे ते सेकंड इक्वेशन. And this is the gives the function and equilibrium constant. And बऱ्याच वेळेला क्वेश्चन असतो derive the relationship between gives the function or gives the energy and equilibrium constant. आणि मग हे तुम्हाला सॉल्व्ह करता यायचं. आणि हा इक्विलिब्रियम कॉन्स्टंट आपण अकरावीत शिकलेलो आहे त्याच्यावरतीच हा रिलेटेड पार्ट आहे. आणि इथं तुमचा काय झाला हा थर्मोडायनामिक्स चॅप्टर काय झाला आहे. नाउ वी सी वन प्रॉब्लेम on temperature and equilibrium. Here this is the problem on change in enthalpy, change in entropy and temperature. For a certain reaction, delta H0 means a standard change in enthalpy is minus 224 kilojoules and standard entropy is minus 153 kilojoules. Joule Kelvin inverse. At what temperature the changeover from the spontaneous to non-spontaneous log. Here आपल्याला काय सांगायचं आहे बा रिएक्शन काय असणार आहे स्पॉन्टेनियस कोणत्या टेम्परेचर असणार ते रिएक्शन नॉन स्पॉन्टेनियस तर गिवन काय आपल्याला मी काय आपल्याला कॅल्क्युलेट करायचं आहे गिवन the value of delta H0 is equal to minus 224 kilojoules and another value delta S0 is equal to minus 153 joule Kelvin inverse. Here see this value is given in kilojoules and this value is given in joule Kelvin. This value is converted into kilojoules or this is converted into joules. Here simply process minus 153 into 10 raised to minus 3 kilojoules means 1 2 3 means minus 0.153 kilojoules. And here T आपल्याला काय करायचं आहे फाइंड आउट करायचं आणि यू नो द फॉर्म्युला टेम्परेचर and equilibrium constant is T is equal temperature is equal to delta H0 the standard change in enthalpy upon standard change in entropy. We substitute the value of enthalpy and entropy. Delta H0 is equal to 224 and delta S, the value of delta S is this is minus 0.15. Here and then joule cancel with the Kelvin with the temperature rate. The answer is 1463 Kelvin. 1643 Kelvin. And this is minus minus, here is plus. Here, the reaction is spontaneous. The reaction is spontaneous below this temperature. Reaction is spontaneous below this temperature. And the reaction is a non-spontaneous. Reaction is non-spontaneous. Spontaneous and the reaction is a non-spontaneous about 1463 Kelvin म्हणजेच रिएक्शन काय असणार आहे या टेम्परेचरला पेक्षा लो टेम्परेचर असेल तर रिएक्शन काय असणार आहे स्पॉन्टेनियस आणि अबव दिस टेम्परेचर द रिएक्शन इज नॉन स्पॉन्टेनियस. दिस इज अ वन टाइप ऑफ प्रॉब्लेम. देन वी सी next problem. Now we see the problem on Gibbs energy and equilibrium constant. And this is the problem for the reaction. Methane gas plus hydrogen gas gives out ethane. Partial pressure of this reaction is 3.356 into 10 raised to 17. Calculate delta Z for the reaction at 25 degrees Celsius. म्हणजे आपल्याला काय करायचं आहे स्टँडर्ड चेंज इन गिब्स एनर्जी फाइंड आउट करायची. फाइंड आउट करण्यासाठी आपल्याला गिवन पाहिजे इन दिस रिएक्शन गिवन Kp ची पार्शियल प्रेशर दिलेल्या रिएक्शनचं 3.356 into 10 raised to 7. Then temperature T is equal to 25 plus 273 degrees Celsius is equal to 298 Kelvin. And we calculate delta G0. Near this formula we use delta Z0 is equal to standard Gibbs energy is equal to minus 2.03 RT into log to base 10 Kp. Here the value of Kp is given, temperature is given, R is gas constant. R is gas constant. The temperature given in Kelvin, that time R is given. as is a 8.314 joule kelvins. Means here the gas constant R is equal to 8.314 joule kelvin. And substitute these values. Minus 2.03 into R means the gas constant, this is constant 8.314 into temperature 98 into log base 10 3.356 into 10 raised to 7. Values are substituted in this equation. And then we take a log of 3.356 into 10 raised to 7, and the value is such as here minus 2.303 into 8.314 into 298 into this 70 into आपल्याला माहिती आहे 33 चा 56 मध्ये काय लॉग येणार आहे 0.526. We solve this we get 10000 joules kelvin. Joules mole inverse, not kelvin, mole inverse. And then divide, we convert into kilojoules, means 100 kilomole inverse. And delta change in enthalpy value किती येणार आहे ही kilojoules mole inverse. म्हणजे ही व्हॅल्यू तुम्हाला मिळणार आहे kilojoules मध्ये kilojoule mole inverse. And this is the problem on gives energy and equilibrium cost. या टाइपचे प्रॉब्लेम तुम्ही बघत चला आणि इथं तुमचा चॅप्टर काय झालाय कंप्लीट झालेला आहे विथ प्रॉब्लेम. Here we rest now. Thank you.